Hi everyone, welcome to our last live session of the semester. Kind of exciting. Next Thursday, Friday, I am going to be out of the office at a training, so we are going to do a review of Unit 5 today and kind of wrap up the semester. I was telling the students in the room with me that this was a PowerPoint that I used last year, and I totally forgot the answer. Did anybody at home figure out how to rearrange 3 of the golf balls? Anybody think that they figured it out? I'm looking at it, staring at it, and honestly, I don't remember. So hopefully you think that's funny, because I don't remember the answer either. So we'll think about that as we're going through class today, but it is possible. So you're just trying to move 3 golf balls so that way the triangular pattern would point down instead of up. No one got it at home either? Then it must have been a good brain teaser. I don't think we had enough time to look at it either. So let's go ahead and we're going to jump in. We are in, it's not week 19, right? No, week 18. Okay, week 18. Here is your essential question. Let me give you a moment to copy it down. It says, what does SOHCAHTOA stand for? And which trig function would you use if you knew the hypotenuse and the adjacent side? So I'm going to jump off the mic, but go ahead and give me a green check mark when you have your essential question copied down. Please give me a green check mark when you are ready, if you're at home. And I will put this back up again at the end. So we're going to go ahead and jump in today. SOHCAHTOA is one of my favorite things to teach because this word is going to help you remember all of your trig functions. So this slide is not part of your notes. I just threw this in here, so we're going to go over it together. It says, which is not a use of trig functions. So to find missing sides of right triangles, nope, we use it for that. To find missing angles of right triangles, we're going to use it for that. To solve a right triangle, we're going to use it for that. So the one that we don't use trig functions for are to find positions on a coordinate axis. So what do you guys notice? What key word is in all 3 things that I have a check mark for? What kind of triangles? Right. Talking about right triangles today. So this SOHCAHTOA thing only applies to what kind of triangles? Right triangles. So here we go. SOHCAHTOA. And this is in your notes, but I like to write it like this. Let me show you why. I write it like this. Capital. Can you add this to your notes, please? Wherever you want. You have empty spots. Okay, the reason that I write it like this is because the capital S, C, and T are your trig functions. We're going to fill them in right underneath. So S stands for sine, the C stands for cosine, and the T stands for tangent. So the reason those are capitals is because those 3 stand for our 3 main trig functions. The other little letters stand for the sides of the triangle that we're talking about today. So anytime I see an O, O means opposite. Whenever I see an H, H means hypotenuse. Where you see an A, it stands for adjacent. So those are your only 3 letters for the sides of a triangle. You have an opposite side, a hypotenuse side, and an adjacent side. So now the letters are repeating. So when I see an H, H means hypotenuse. The O, again, would stand for opposite. And the A stands for adjacent. So let me give you a moment to copy that down. Again, the 3 letters are capitals because those are our 3 trig functions, our sine, cosine, and tangent. And then our little letters stand for our sides of our triangle. So we're going to practice these today. So if I tell you we're trying to find the sine of an angle, which two sides of the triangle am I going to use? The opposite and hypotenuse. If I tell you we're finding the tangent of an angle, which two sides are we going to use? The opposite and the adjacent. So SOHCAHTOA, if you write that at the top of every paper, it is going to tell you which parts of the triangle to use for each individual trig function. After we practice, it gets super easy. So on this paper, we are going to draw a triangle. So everybody go ahead and draw one for me. Has to be a right triangle because that's the only time SOHCAHTOA works. So go ahead and draw on that right triangle for me. I'm going to highlight my H. There's a reason I'm highlighting H. H is always a very specific part of your triangle. H never changes. So no matter what triangle I give you, there's only one hypotenuse ever. How do you find it? It's the longest side. And how do you know which one is the longest side? It's always straight across from the right angle. So right now, can we all agree that my highlighted in yellow is my hypotenuse? Everybody okay with that? Go ahead and label it on your paper. Label it on your notes. So this long side is my hypotenuse. Now I have two sides left to label. One's the opposite, one's the adjacent. The second easiest side to label is opposite, and here's why. Let's find the angle that they're talking about. If we're talking about angle A, the opposite side is the one that's directly across from it. So does that mean the 3 or the 10 is my opposite? Which one's straight across from the A? The 10. This is your opposite. Everybody okay how I found that? When we're labeling our triangle, we always do it in a specific way. The first side you label is your hypotenuse because it never changes, right? It's always the longest side. Secondly, we label our opposite. Opposite is always straight across from the angle we're trying to find. And what would that make my 3? What's my only other word I have left? Adjacent. Adjacent means it's the neighbor. It's touching it. It's neighbor. So adjacent is always the one that's touching it. You see how A has two sides that are touching A? So in the beginning, if you didn't label your hypotenuse first, you might think that's your adjacent side since it's its neighbor, but it's not. So we always label them in order. Hypotenuse first, opposite second, adjacent's the one that's left over, which is its little neighbor. Any questions about how I labeled hypotenuse, opposite, adjacent? Watch how we're going to use our trig functions. If I know the opposite, see how they gave me a 10 for my opposite, right? They gave me a number. What other letter did they give me? Adjacent. See how they gave me those two numbers? Let me highlight them real fast. They gave me the 3 and the 10. So what letters did they give us? The A and the O. Which trig function uses A and O? See how that uses A and O? That's how I know what trig function to use. If you write out SOHCAHTOA, it's going to label it for you and give you the letters to use. So for this example, I would write tangent of A equals opposite over adjacent. So when these letters are side by side up there, it's really like this, opposite over adjacent. So I'm going to say 10 over 3. We're going to keep practicing today. Today's all about trig functions. The number one thing to know is you have to memorize SOHCAHTOA. It is going to help you immensely. So let's do a little bit more practicing. Okay, definition of sine. Sine, remember sine is our on the SOHCAHTOA. So sine is opposite over hypotenuse. Everybody okay with that? Sine's opposite over hypotenuse. So if I want to find sine A, they're talking about looking from this angle. How do I find sine of A? Which one's my opposite side? A. Which one's my hypotenuse side? C. See? Opposite over hypotenuse. We're going to try using sine again, but this time I'm having you start looking from a different angle. So everybody look at angle B. Now that I'm looking from B, which side is your opposite side? B is opposite. Which one's your hypotenuse? C. Opposite over hypotenuse is B over C. So do you guys see how the numbers changed, right? I had A over C here, but I had B over C here, even though it's still saying sine. So the key to these problems is that you're starting from the angle they're asking you about. So if I'm looking at A, the opposite from A was over here. If I'm trying to find B, the opposite of B was over here. So you always have to pay attention to which letter it's asking you about. Let's try cosine now. Cosine is what part of SOHCAHTOA? The ka, right? SOHCAHTOA. So for cosine, I'm always looking for the adjacent and the hypotenuse side. Everybody okay with that? We're doing the middle part of SOHCAHTOA now. So let's try looking at cosine A. So if I start at A and I want cosine, I have to pick out the adjacent side. Now we said adjacent's the neighbor, right? But I kind of have two neighbors here. So we have to ask ourselves, which one's the hypotenuse and which one is really the adjacent side? That hypotenuse would be your C, because that's always our longest side, which means that B is your adjacent side. So whenever you're looking for its neighbor, remember, you always want to identify hypotenuse first. It's always the longest side. Then the adjacent's the other one that it's touching. It's kind of like the leftover. So if I'm looking for cosine, I'm going to say adjacent B over hypotenuse C. We're going to put numbers in here in a minute and actually solve some real math problems, but it's important to understand how we use each of the trig functions first. Now everybody circle your B. Everybody circle angle B for me. If we're talking at cosine, please pick out, and I know I gave you the answer, but we're just trying. We're just practicing, seeing how they got these. Which side would be the adjacent side? Because it's really touching A and C. So one of those is your adjacent, one of those is your hypotenuse. So hypotenuse is still which side, everybody said? Longest side, which is C, which means that your adjacent would be your A. So adjacent over hypotenuse. Questions before we try some with numbers? Because you're thinking, what do I need this for? There's a lot of letters going on. Okay, so we're going to try. I'm going to ask you to write out your fraction. So if I ask you for sine A, we're going to do the first one together, then I'm going to let you fill in the other ones. So everybody look at angle A. We're talking sine for the first one. Let's write out SOHCAHTOA again at the top to remind us. So I'm talking sine here. What number is going to go on top? The opposite. What number is going to go on the bottom? The what? Hypotenuse. So opposite over hypotenuse. So let's try. If I'm talking about angle A, which one's straight across from angle A? Everybody says? Little a. And which one's H? Which one's the hypotenuse of this triangle? C. Good job. So take a minute, see if you can fill in the rest. It just takes some practice. So now let's look at the second one. We're talking cosine. Cosine is adjacent over hypotenuse. So if I'm looking for my adjacent side, that would be its neighbor. So we're talking B over the hypotenuse, which is C. So no matter what formula I'm using, does your hypotenuse ever change? No, hypotenuse is always the same. The only sides that change are if you're talking about your opposite or your adjacent. Those are the only two that change based on the portion that you're looking at. Let's look at it from a different angle now. Let's check out B. So here's B. Let's do sine first. Sine is opposite, should be B, over hypotenuse, which is still C. Doesn't change. Always C. for hypotenuse. And then lastly, let's try cosine. So cosine, again, is adjacent over hypotenuse. So hypotenuse is still C, but your adjacent side would be A. How do we do? We're getting a little bit better. Just takes practice just to be able to pick them out. Now we're going to try numbers, because you have to first understand the trig functions before we can add some numbers in here. Okay. It says find the sine of each angle. We're going to start off with the sine of A. So everybody circle A, please. Let's write SOHCAHTOA at the top of our paper. If we're talking sine, we're looking for opposite over hypotenuse. So everybody start with A. Please pick out your opposite. So from A, which number is your opposite? Everybody says? 16, great. And which one's my hypotenuse in that picture? 20, great job. Any questions on the first one? So far so good. Let's try sine B. I'm going to move that. Let's circle B. Oops. Okay, circle B. Still talking about sine here, so I still want, what's the opposite of B? What number? 12. Over the hypotenuse. What's the hypotenuse? 20. Great job. This isn't actually an angle. And you're thinking, how is that an angle? When I solve this problem, I'm going to get an angle as my answer. Here's how you solve them, and I know most of you don't have calculators with you today. Have you guys ever noticed on a calculator how you do have a sine, cosine, tangent button? Have you guys seen those before? If you have a phone, do you have your phone? Can you tip your phone sideways? Your phones are going to do these problems for us. And if not, when you get home, you can always search the internet for free calculators. So let's try and pull out our phone. And if you tip your phone sideways, it gives you what's called a scientific calculator. Do we see sine, cosine, tangent? How about people at home? Do you guys see sine, cosine, tangent? Yes, Gary. So H's are not the ones we're going to do today. Yeah, don't worry about the ones with the H. You're just looking for the ones that say sine x. Everybody good? Or you're just say sine? Perfect. It'll say sine x or sine. Do you guys have a key that has a second button? Yeah. Okay. Yeah. Here's why. Think about when we solve this problem. 2x equals 10. How do I really get x by itself? What am I doing? Dividing by 2. Everybody okay with that idea? When we're getting a letter by itself, we have to do the opposite of what's there to get it by itself. Here's the problem I'm trying to solve. Sine A equals 16 over 20. I am trying to get the A by itself to know what this angle is right here. Everybody still with me? Okay. I'm basically solving a math problem. I'm trying to get the A by itself, because if I can get the A by itself, it's going to tell me what degree A actually is. So I have to get rid of this sign. Right now, this is sine of A. So the way that I get rid of sine is what we call the inverse. So on our calculator, what we're really going to do is sine to the -1, 16 over 20. And that's how it gets our sign to go away. So what I need you to do is hit your second button, hit sine. See how once you hit your second button, you get the sign to the -1? Are we nodding at me? Okay. And then in parentheses, do 16 divided by 20 equals. And let's see what you get. So we're looking for sine to the -1, because that means the inverse of sine. That's how we get the sign to go away, leaving A by itself. So we're really doing second sine, and it will look like this. Sine to the -1, 16 divided by 20, hit your equal sign, and we should get 53.1-ish. Ish. I'm very mathematical today. Ish. Rounded. So let's try this. Can we try this way? Everybody type in 16 divided by 20 first. Okay, so 16 divided by 20 is 0.8. Everybody with me? Okay. So let's do 0.8. Some calculators, you have to type things in a little bit backwards. So we're going to try it backwards. Ready? So type in 0.8 and then do second sine. Now that we get 53.1? Okay, good. So each calculator is a little bit different, so I can come by and help you, but knowing the final answer will help you certainly get there. Yes, that's the degree. So we just found that this one's a 90, this one is 53.1, and now we're going to find angle B. So we're going to practice again. Let me hide this little section down here. So let's try this one sort of like we did the last one. Can you guys work out what's 12 divided by 20 first? 0.6. You guys at home, you trying that? Did we get 0.6? So with 0.6 in your calculator, leave it as 0.6 and do sine to the -1 and see what you get. Good job. 36.9. Then you're not typing it in right, but I'll come by and help you. Guess what happens if I add all three of my angles together? What do you think I'm going to get? 180. Because that's a triangle. 180. So let's try again. The first time we try something is always a little wacky. It feels kind of new. It feels kind of funny. So we're going to try again. We're going to try cosine. So let's write SOHCAHTOA at the top of our paper. Which portion of SOHCAHTOA are we using? The AH, which is the adjacent over the hypotenuse. So everybody start looking at A. You need to figure out which one's the adjacent and which one is the hypotenuse. I know, they're the same numbers, but I changed it to cosine this time, right? Okay. So, what's my adjacent side though? Which one's adjacent? What does adjacent mean? Neighbor, right? It's neighbor. That's 12. And my hypotenuse is 20. Let's try cosine of B. So let's switch and look up at B. So now that we've switched our vantage point to B, which one is the adjacent? Which one's the neighbor? 16. Which one's the hypotenuse? 20. We're going to try these again in our calculator. So let's try cosine A first. We know 12 divided by 20 is 0.8. So I'd like you to type in 0.8 cosine to the -1. See what you get. And then 16 out of 20 was, oh no, 16 out of 20 is 0.6. Sorry, this one's 0.8, this one's 0.6. I know, I'm making mistakes on the last day, darn. So when we take cosine, do we get the same answer or different answers? What do you think? They're the same. Yeah, they're the same. So here we have a 53.1, and here we have a 36.9. What this is showing us is that, wow, don't send Mr. Collaborate having issues. What this is showing us is that when I have a triangle and they give me all three sides, which trig function can you use if they give us all three sides? Did cosine work? Yes. Did sine work? Yeah. So if they give me all three sides, which one do I have to use? Sine, cosine, tangent? The answer is any of them will give you the same answer. Everybody okay with that? When I give you all three sides of the triangle, any one is going to give you the same answers. That's good news. It means there's not a wrong one to pick. All right, I'll help them in a minute. So let's try out tangent now. Tangent's just the last of the three. So tangent for SOHCAHTOA. So now we're talking about the TOA portion. So if I'm looking from A, the opposite would be straight across, and the A is the adjacent side. So the only one that's not used in the tangent would be the hypotenuse, right? The other two sides are used. So let's try one. There we go. So go ahead and please write out what you think your fraction would be. If I'm looking, what angle am I starting to look from? Angle B, it tells us in the problem. Please write in your opposite over your adjacent side. This is a 3, 4, 5 triangle. So Gehrig, which one's my opposite side? The 3, good. And Daniel, which one's my adjacent side? Okay, there's 2 Daniels. Thank you, Daniel. How do I solve this though? If I want to know B, how do I get B by itself? What do I have to do in my calculator? I have to work out what's 3 divided by 4. Everybody says, if you have 3/4 of a dollar, how much do you have? 75 cents. Right? 3/4 out of 4 quarters, 75 cents. So I'm going to do, how do I type it in though? Tangent to the -1. What do we get? 48?
36.8.
Yeah, that's what I got too. I got 36.9. You don't. You use a calculator. Yeah, you're allowed to use a calculator. The question was, how do we solve these on paper? And the answer is you don't have a way right now. So let's try a couple examples. Here we go. I'm asking you to find the length. I'm asking you to find the length of A to C. So for A to C, let's put an X. This time, see how I didn't give you all sides of the triangle? There is a right and a wrong one to pick this time. So I'm going to teach you how you pick the correct SOHCAHTOA, which one to pick. SOHCAHTOA. We have to look at what information is given to us, and then we're going to pick if I'm using sine, cosine, or tangent. So look at the angle that they gave us. They gave us A. Okay. So let's look from angle A. They're giving us 2 other pieces of the puzzle. They're giving me 53, and they're asking me to find this one. So we need to label our side. What information did they give me? They gave me the angle, but what would I label 53 as? What part of the triangle is 53? It is the hypotenuse. How did you know that? It was the longest side. It's because it's the one that is where? So how do we pick out the hypotenuse every time? The one straight across from the right angle. Okay, good job. How about the X? X is what I'm trying to find. X is the one I'm trying to find. Which side do I have left? Is that one my opposite or my adjacent side? Adjacent side. So if I have an A and an H, which trig function am I using? Which trig function uses the A and the H? You guys okay with how we picked that one out? You have to label your triangle first, then you're going to pick the appropriate trig function. So how do I do this? They gave me the angle this time. That's weird. They haven't been giving me the angle before, right? This time they did. All right, let's think about it. Usually it's like this. Cosine of my angle equals adjacent over hypotenuse. So what do I plug in this time? Cosine of, what does A mean again? A is your what? Angle. Did they give it to me? They did. I'm going to put a 26 in there. What's my adjacent side? X. What's my hypotenuse side? 53. So before, my unknown, the one that I didn't know, was my angle. This time, my unknown's just one of my sides. This is way easier than the last one. Watch this. Every time I solve a math problem, it's always to find my one that I don't know, right? Find the angle you don't know, find the side you don't know. I don't know this one. How do I get that x by itself? You are this close. Anybody know? Isabella? Perfect. So to get the x by itself, all I have to do is get rid of that 53. How do you get rid of a divide by 53? Multiply by 53. So I'm going to have to multiply that out in my calculator. The best way to do it is sort of backwards, forward. I know it sounds funny to do it backwards, but most of your calculators don't have big honking screens like mine do, where you can put a whole problem in at a time. So here's how I recommend you type it in. 26 cosine, hit enter, and then do times the 53. Okay, so see how I'm just sort of going right to left. 26 cosine, hit your enter key, times by the 53 that's out in front, and let's see what answer we get. You're going to get an angle. So if you have a fancy calculator where you can type all of this in at one time, awesome. But if you're using your phone, you kind of have to work your way backwards. So 26 cosine enter times 53. Why is it multiplied by the 53? Because they are touching. And anytime in math when things are touching, what does that mean? Multiply all that together. Anybody try it? What do we get? Excellent. Good job. Question? Should we try again? It's always new. First time's always new. Kind of funny. Okay, let's try again. Good. 47.6, yes. So this time, we're going to find the measure of A. So let's all circle A. We have to figure out what trig function to use. How do I know I can use SOHCAHTOA? Because it is a right triangle. So SOHCAHTOA. Which two sides did they give us? Let's label them. If I'm looking at A, what would the 13 be considered? Which side? Opposite. What would the 53 be considered? Hypotenuse. Because it is the longest side and it's the one across from the 90. So what two letters do I have? O and H. Which trig function do I use with O and H? SOH. See if you can set up your problem. Plug in your numbers. Did they give you the angle? Did they not give you the angle? What did they give you? What are we solving for? So your paper should say sine of angle A, because they didn't give us the angle this time, equals 13 divided by 53. How'd we do? Most quizzes are going to leave your answer like that. Doesn't that seem nice? So nice. If they don't, how do we finish solving for what A actually is? You have to use a calculator. So it's absolutely fine to Google a free calculator, use it on your tests and quizzes. That's fine. They're expecting you to. We cannot do these by hand. We can't solve the second inverse of the sine by hand. We don't do that. So let's work out 13 over 53 first on our calculators. And I got like 0.245, and it just keeps going. So we plug that in. And then how do I get this A by itself again? What do I do to solve for sine? Kind of. She said cross multiply. Kind of. Sine has a weird way to divide sine. We don't really divide by sine. What were we using before? Do you guys remember? Was sine to the -1. It's the inverse of sine. So whenever we're trying to get a variable by itself and we're trying to get rid of a trig function, you have to use sine to the -1. This is what we started class doing today. So by the time we plug all that in, we are going to get, what'd you get? Anybody? Let me try it. Good. And I'm going to round. I'm going to say 14.2. 14.2. Once you know two sides of the triangle, you could find the third if you wanted to, right? All three add to 180 if we wanted to. I'm just throwing that out there. Or you could use the trig function to find that one too. It's your choice. Okay, one more. Let's practice. It says use an inverse function, to find the measure of angle L. So let's circle angle L. Can you please label your sides of your triangle opposite, adjacent, hypotenuse? Technically, you should label hypotenuse first. Which two letters did they give you for SOHCAHTOA? A and H. We're always going to label H first, right, longest side. Then you're going to label your opposite side because that's the easiest one to pick out. Which one's always left over? Adjacent, which is the neighbor. So which two do I have numbers for? A and H, which means which trig function am I going to use? Which one's AH? Cosine. Now this word doesn't seem so weird anymore, right? It's super helpful. Super helpful. So we're going to say cosine of L equals adjacent over hypotenuse. 5, 4. We're going to work out the division portion first on a calculator. This should be a 8.54. So I'm going to get cosine L equals 0.66 approximately. How do I solve for L? How do I get L all by itself? I can't just divide cosine because our trig functions have weird rules about how we get rid of it. So when I'm using a calculator, I'm going to type in 0.66. What do I do with the cosine again? Cosine to the -1 equals 40. Oh, close. I didn't get 48. Did you? Let me try. Second cosine. Oh yeah, I just wrote it down wrong. 48.7 I got. Anywhere in there is good. It all depends on where you rounded your initial problem. 48.5, 48.7 is close enough. It really just takes practice with the calculator. So that's my advice to you. Now that you kind of have some answers in your notes, just go home and practice. We're going to end with one more. We're going to find the height of a tree. Did you know that they actually use SOHCAHTOA when they're finding heights of buildings? Because do you think they put a tape measure up to a building and measure how tall it is? No. No. They're going to pick a point or a shadow just like they're doing with this tree, and they're going to find the height of the building. So if I had my whole class in front of us, we actually make these little protractor things with a straw where you can look at the height of something, and it dangles a string and tells you what angle you're looking at, so it lets you measure how tall things are, which is super cool. And believe it or not, you know what else I used SOHCAHTOA for? We were building a shelving unit under my stairs. So we knocked the wall out under my stairs to do a built-in pantry. I had to know what angle my stairway was at so that I knew how to level my shelves. So I actually used SOHCAHTOA, and my husband's like, "What are you doing?" And I said, "I'm using SOHCAHTOA to figure out the angle." Anyway, so sometime you might use it in your life if you're building stuff. Ask Mr. Hayden. Ask Mr. Hayden. He builds lots of shelving units, and we did some SOHCAHTOA too at the beginning of the school year. Let's try. I want to know how tall the tree is, and I am given this angle and the 30-degree angle and this length right here. So let's see what we know. If here's the one I want to find, I have to use x for sure. What other number do you think I should use? What angle do we want to look from? There's not a wrong answer. What angle should we look from? The C? Should we try looking from C? Okay, so let's start with C. Everybody circle C for me. Which other side of the triangle did I give you? I gave you the 10, right? What would the 10 get labeled? Which side is that? Opposite. How about the X? Because X is the one I'm trying to find. What would X be? Adjacent. Great. Here's my SOHCAHTOA. If I know O and A, which one am I using? What's O and A? TOA. Great. Tangent. Look how good you guys are doing. It only took me 30 minutes to get there. You guys are doing excellent. So we're going to say tangent of what? Okay, I'm hearing 30. I'm hearing X. I'm hearing we don't know. I'm hearing. So let's try like this. Normally it's like this, right? Opposite over adjacent. That's the original. A is always the angle. Looking from C, did they tell you the angle? Ah, they did. So I'm going to put a 30 in there. See what I mean? Okay. And then my opposite is 10, and my adjacent is X. Which one am I solving for? X. X is the one I want to get by itself. How do I do that? With math? Yep, that's correct. Our last Friday together, yes, math is the answer. Okay, so how do I get X out of the denominator? I need to fix it. Close. Okay, watch what I'm going to do. Right now, if it says divided by X, what's the opposite of divide by X? Okay, multiply by X. That's going to get it out of the bottom. Everybody agree with that step? Am I allowed to do that as long as I do it to both sides? Yes, I'm allowed to do that. So now I have X times tan 30 equals 10. How do I get this X by itself? You're so close. Look what's going on. It's X times tangent 30. How do I get rid of the times tangent 30? Divide by? No. If you divide by X, you're going to get back. You're going to get back right here if you divide by X. Trying to get X by itself. How do you get rid of a multiply by tangent 30? Divide by, tangent 30. There we go. These are all allowed. These are all appropriate math steps. You're allowed to do it. You're just moving things to and from. So we've got to work it out on our calculator. You do 10 divided by tangent 30, and we will get 17.3. When I divided. So in my calculator, I did 10 divided by tangent 30, and I got 17.3. Okay. Hit equals again, and you probably get 17. Let's try one other thing. Watch. No, it's not a trick. It's not a trick. I just want you to watch something else. Because what if I was looking from this angle? Just watch real fast. This is like the other one we did. I would know my opposite and my adjacent. If I do it in blue, opposite and adjacent is still tangent. So this one is tan 60 equals X over 10. How do I get the 10 by, or how do I get the X by itself? Times by, how do I get rid of this divide by 10? Times by 10. Okay. This is going to give us the same answer. 10 times tan 60. So my point is, there's no wrong angle to pick to try. Some are easier than others. So if you get this big mess and you're like, I don't know what to do, try a different angle and it will be an easier version of the problem. Not wrong, same answer, just some of us have a harder time looking from different angles than others of us. So this is a lot of information for today. There were still 2 sections that I'm not going to do today because this was already enough to load your brains with, but you still have a lot of, because remember how right now these are all for right triangles? You guys agree? These are all for right triangles. You have 2 theorems left this semester for when you don't have a right triangle. Okay? So that's going to come at the end of this week or next and early next week is law of sines and law of cosines. So that's the last 2 things that you guys have left. So I'm going to jump to the end real fast. Okay, and it's not week 19, sorry, it's week 18. And again, my essential question is just what does SOHCAHTOA stand for, which now we should know for sure what all those letters stand for. And which trig function would you use if you knew the hypotenuse and adjacent side? So if you know H and A, which one do you use? So those of you at home, please put that in the drop box. Have a great week, and let me know if you have any questions. This was our last live session. Thanks, guys. Bye.